Okay, so I wish I could go back time and burn back a couple of days. There's a way to do it via the top, but it's not going to be real great for employments and things like that if you got to go up and tell people that, hey, I had to report a company to Better Business Bureau. I don't know what'll happen with it. I just sent them an email, told them what the events, times, and dates of some stuff were between Employment Solutions and Meadows Park and Deposit there. Man, I was so stoked to get a job down in there. I was all excited. I was going to be able to see my grandma frequently. I thought it was a great job, get me out of the stone mill, keep me away from the concrete factory. I was a landscaper before. I've done carpentry before. I've trained people before. I've done gantry saws, some of the biggest equipment in the area, short of whatever the town or the state's going to be slinging for equipment and loaders, right? That's going to be the top end of it. I've not much experience, but I've driven a dozer before, and I've been trusted on people's property. As a landscaper, you got to be on people's property to do stuff. As a carpenter, you got to go into people's houses and do stuff. And never once have I been fired or terminated on things. So let me start today by, I want some super bizarre quantum erase experiments to go on today. Make me think about something else while I'm dealing with it. Fermilab guy, square me away, my man.
In my last video, I talked about how the double slit experiment was mind-blowing. How the particle passed through the slit depended crucially
you have your
on whether someone was detecting
the
particle
divergent flow once I pass through the door of a building.
I'm going to show you how
there are multiple in the stone mill, specifically in Delaware Basin.
Let's take a look, shall we?
Where I do my walkthroughs, I talk about it as if you are a particle. I say, as you move through this building, you're going to move with quantum time, quantum gravity, towards whatever was presented on the billboard to whatever your station mechanics are. Here's another example. When you're programming saws, sometimes you have 12s, 14s, 16s, 18s, 20s, 24s, so on and so forth, as much as specialty cuts. Those could be the potential of what any block looks like. Now, obviously, there's some limits, but when you get to the big saws, that gets cut down. But they're still inch, inch and a half, 2-inch, and any kind of specialty cuts that go with that type of system off of their standard model. Now, when you know that momentum, that's the way it's going to go. There's some base gravity that usually always the best money on the most sales goes to 2-inch, 4, 5s, and 6s. Footers. Now, when you're cutting on the big saws, you don't necessarily. You can cut 8-foot rock, 12-foot rock, or 8-foot rock, 10-foot rock, and 11 or 8-foot, 10-foot, 12-foot rock, excluding any half-size foot. Now, you can cut anywhere from 3, 4s, 5s, and then from there 6s, which if you have a 12-foot block, you can cut 12-foot or 2 6-foot blocks out of that on the tread saw later. I've headed off blocks before. I've cut blocks in half for specific size orders. Let's say I had an 8-foot block. I've cut them down into 4-foot blocks so I can have 2 4-foot blocks and get more 2-foot cuts out of it that way. It's a little faster. That's what the particle slit experiment's talking about. When Feynman went to the teacher in the class and said, well, what if there's 2 slits? Or what if there's 3 slits for this experiment? When those things are not determined by orders or coefficients, that's what you can do. Let's load a backloader. You could dig a hole. You could pull weight with it. You can do a lot of things given what trajectory that goes through. Now let's say that's the order board that says, well, we're going to dig a hole specifically this deep. How long does that take is going to be, well, let's start with the maximum depth. Let's say arbitrarily 8 foot. It takes 5 minutes to dig a hole, or well, let's do something stretched out a little bit. Let's say 10 minutes to dig a 8-foot hole. A half hour to dig an 8-foot hole, 4 feet wide, well, 2 foot wide by 4 foot. 4 foot long, 8 foot deep. Let's say it takes a half hour to do something like that. As you back off the ratio of how deep that goes, that's going to alternate a Jacobian matrix to the standard model of the dig coefficient on that loader, right? So that's to say that's a quantum experiment. There's, in the matrix of all of those forms, that's how you determine the best quote. that's where you would say, hey, do I hire this loader or this backloader or this backloader team? And you might have multiple slits on those things. They might have a heavy specialty. They might have multiple matrix to the overall of the state index or whatever, Better Business Bureau or safety standards, OSHA, occupation safety and hazard, any experiences that they have, licenses that they have. They change the spin ratio in terms of a very specific value at the top end. That'd be Andromeda Paradox. You go with the fastest one first. Okay, so the Andromeda Galaxy, as much as the Milky Way Galaxy, is a particle. When you say, well, what's the mass of Milky Way Galaxy, you're not individually checking every star, are you? You're ranging the approximation of, let's say, y'all remember the penguins in Alaska or Antarctica experiment where you bust it down into grids and you say, well, in average, 3 or 4 of those grids all have roughly the same number as I count small scale, so if you do the whole area there, you get an approximation of how many stars are there. If you give them all a regular value, or even if you want to be more comprehensive about that by O-type stars, A-type stars, B-type stars, C-type stars, O-type stars being the largest blue hypermassive giants and red hypermassive giants out of the game, they're going to augment the system. We're talking about solar masses here, where the mass of one flaming hydrogen sunshine supremo will start to compare less than the mass of the sun, red dwarf, white dwarf, but white dwarfs kind of work on that wave operator where they might have the mass. I'm not exactly sure of the number. But when you get to heavier and larger star types, they'll start to go 100 masses of the star. So you take all of those by averages and you clean them out by spectrums and wave functions to get you the approximation of what the mass of that solar system, or the mass of that galaxy in this case would be. And that's a black body radiation problem. If I'm appropriate by all of these bumps and systems, and they correlate over an arc or under an area to correlate to the same time is equally fuzzy, and its location. So those are the kinds of things you're dealing with, and you can do this all the time with crew. This is a quantum experiment. How do I orientate and arrange the tread line? Now, most of those guys are fixed. 10-year vets, new rookies. How am I training the skill criteria? If I've used the thermaler station before, motivation, determination, quality. Those are all sectors of ways to describe it. Now, you can have bars and sectors where it says, well, you know, he's got motivation, but necessarily not the determination to be able to burn rock like that all day. Happy to do it, doesn't get upset about a thing. That's usually going to be a Sawyer's type of position, where great with the thermaler on it, and you can do multiple things. It'll probably make you an operator or even a trainer or something along those lines. And of course, at that point in time, you could also be a Sawyer. But it really depends on the ratio of that mix and whether you're actually graphing the calculus behind that by the derivatives or coefficients. You know, the law of diminishing exchange of tracking that stuff over time is kind of hard, so you do it small scale over the day by percentages. Well, that was one of those things. It'll come up on the ledger later about team meetings on systems about, well, last week, Larry, you know, that's going to compound into that system equally like how many of those incidents you have. Those would be individual cells or slits that experiment walked through. Now, that can be polarized and it can be on an angle. So if the angle is straight up and down, I need a thermaler through the system and a thermaler on the output, and the resume is congruent. This is to say that it could be this or it could be this given the rotation of the distance of that operator given training, or how long you're willing to train those things, whether that experiment is going to be conducive with that type of slit mechanics. And you're going to get into some heavy duty stuff like that, but in itself it's actually very simple material. Well, I wish there was more to it like that, but again, you know, you're going to go through this with a ball and a graduated cylinder with a steel ball, a ball in air, ball in water, ball in fluoroammonium acid, and they each give a valid result on their own. But if it's specific to the field in which you want it to do, let's say you wanted to create a sound effect, then obviously the largest of sound experiments would be in an empty beaker. Cling, 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 cling. If you wanted to reduce that in some way, you would say a ball in water. Bloom, cling. You know, it would slow it down quite considerably. And if you wanted that to potentially dissolve that, blink, blink, and it'll burn away in a certain timeline. Equally like, well, fluoroantimony is the world's strongest acid. So you're going to start with ranges of weak sulfuric acid, just basically rainwater, sulfuric acid rain. The very weak composition, maybe around, I think it's 6 for acid. I think the acids are on 1 through 7, and then 7 through 14 is going to be base. You know, as you're working that kind of material, it kind of gives you a rough estimate of how corrosive it is, but it's only corrosive to the ions in that element. So in your skin, you got silica, you got carbon, you got iron, you got nickel, you got compositions of everything that makes up the body. Probably not any radioactive isotopes, but I'm sure you ate a banana at some point in time, so there's going to be some potassium in the skin. That's has a lot to do with water retention. If you've ever given or know anything about silica solution in an IV bag, sometimes they'll load those up with potassium and things like magnesium and stuff like that. But the proper salt for what that is, potassium salt, magnesium salt, or whatever combination that is. I really don't have a strong medical back in that system, but you can use X-ray vision in a lot of this ways to kind of determine that kind of system. We're just saying, well, this thing is going to emit an X-ray to determine what kind of value at the specific high frequency radio burst that is produced from that value. And that would give me an indicating system in general to not necessarily determine how powerful that burst was, but potentially over multiple of those indexes, the mass more in-depthly of the black hole or galaxy in its entirety of that system. And you go begin tracking that kind of stuff, and that's going to give you a comprehensive model or field theory at least about that type of mechanics. Now yeah, sure. Well, yeah, there we go. Well, let's backtrack a little bit here. Whoa, Fermilab, where are you going? All right, so let's look at the diagram here. We have E2 to this is probably a photon, antiphoton, photon, gluon, electron, or well, this is an electron. This is a neutrino. I think the value would be negative there for the neutrino. And we're saying that the neutrino is coming in and it's releasing a electron. And inside of here, there's also a release of, because that changed forms, that's going to turn into photon, light, potentially sound at the antiphoton, and actual light with a gluon. So what's a gluon? Well, it could be a shock wave. It could be heat. It could be a lot of those things inside of this fuzz. Now, conversationally, you have to think that I'm shooting one of these diagrams at you. Click, 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 click. Are you getting any sound, auditorial things going on? What are you thinking about equally, like what's the visual on that function, and how does that correlate to today? Will it change the value on a system? Will it augment the form in some way to now change your results, or at least confirm your results potentially? Like, that's the heat emission, that's the value in that form. So I talk about that like it's E2. E2 is a chess pawn. So in front of E1, which is the king, inside here, E1 to E2, which is usually how that diagram goes, but we're going to quantify it. Hey, don't be getting too frosty with me. I actually be careful with that. Don't think I know what I'm doing. I study this stuff every single night. Every time these guys throw something up and I can check out a research paper or a name of one of the researchers or something like that, I'm usually on it. But that's a drywall example. You know, there's 2 ways to fix a hole in drywall, right? You know, somebody punch the hole in the wall, you can throw the mesh on it and the paper and then the spackle or the drywall compound, and that'll fix it up, sand it up, and done. But there's also a kind of a hole saw you can make, drill it out, drill a hole out in new drywall, put that in there with the paper and stuff like that, lay it on the paper, lay it on there, and then do it that way to make sure that it's really secure that way too. And those are both valid diagrams. Now, which one's coming at you which way? Maybe it's time relative. Maybe it's cost relative. Maybe that in that set changes the value to be gravitationally the correct move, the proper geodesics or timeline or cost ratio, something of that matter. Catch you on the next one.